I'm Alan Ross. I'm the managing editor of APC Technologies, and we are here at the NETA, the International Electrical Testing Association, their 2023 PowerTech Conference, doing interviews. My guest with me is the Director of Communications for APC Media, Rachel Linke. Rachel, thank you so much for being here.
Absolutely, Alan. Would miss it.
We're just going to have an interesting time with all of these people, and tell me what you like best about these interviews.
The best part about these interviews, I feel like, is that it really brings about a lot of great thought leadership, and I really just love how you make everybody feel so comfortable, Alan. You really try to get people to just be comfortable and in their own skin, and then so much great information comes out of it. So
let's see if we made people in the next interview comfortable. Enjoy. Okay. My next guest is Craig Goodman. He is the president of the HV Diagnostics. Thanks for joining me, Craig. So you're in South Africa. You're in the southern part of the hemisphere. You're so far away from us, but you're here at NETA. Tell me a little bit about what you get out of coming to NETA.
So actually, Alan, I grew up in South Africa. I spent my childhood there.
Yeah.
And just before I turned 30, I got an opportunity to work here in the US. And I took that opportunity, and we started a company 24 years ago. And look at today, and I'm the president of that company called HV Diagnostics. To give you a bit of background, I grew up in South Africa, as you mentioned. And my father was an electrical engineer.
Oh, cool. That's excellent.
3 other brothers.
Yeah.
None of them wanted to do anything technical.
Yeah.
I was the only foolish one that did. And obviously grew up under my father's guidance. I started hot-potting cables at the age of 12 or 13. Yeah. My dad needed free and cheap labor. He got it in me. And I started at a young age crimping cables. I've crimped more cables than I can wish to remember. And that gave me an insight into the industry. And lo and behold, I studied electrical engineering, luckily graduated, and here I am today enjoying the fruits of getting that degree and enjoying the industry thoroughly.
And you've been in the U.S. how long?
24 years. Came in 1999.
Where's the company headquartered?
The company is headquartered in Atlanta, just north of Marietta. And,
I live in Marietta. I went to Georgia Tech.
Did you?
I love, that's my home. That's excellent. We'll have lunch sometime.
We should. Yeah.
And so I do want to get back to South Africa, because there's a reason I brought that up, and it is basically something that was really good has turned to be something that needs to be better. So we'll talk about that. Before we get there, I want to talk about the industry here in North America, where we are, what's happening. In our industry, in the power industry, there is so much change. Distributed energy resources, wind, solar, batteries, everything. And a lot of the equipment that you do testing on, including cables, they're all changing. Everything seems to be changing, which means the test equipment must change, which means the training must change in order to be able to support all that. Talk a little bit about the challenges that you see with all of those things changing.
Right. I can talk specifically about cables. And cables obviously are the backbone that link everything together. You can go overhead, but more and more is going underground into cables.
Very much so.
And traditionally, what was done? Testing a cable was either nothing was done, turn the breaker on, close the fuse, and then people started doing the DC hot pot. But what's been found in the last 20 to 30 years, both here in the US and in Europe, and around the world, is that the DC hot pot was found to be pretty damaging to particularly extruded XLPE cables.
Okay.
And so what we found is that over the last 20 years, more and more sophisticated techniques have come about in order to test these cables correctly. Not only provide the testing of the cable suitable for service, but to do diagnostics on the cable as well. And so in about 2002-03, the IEEE standard and EPRI did some research, changed, and it went from a DC hot pot, very simple pass-fail type test, to what we call advanced diagnostics, which include things like tan delta diagnostics, partial discharge diagnostics. These were a lot more sophisticated than a random DC hot pot.
Right.
And so the training aspect, as you mentioned, has become very critical. And so we've spent a lot of time and money at our facility building a training facility where we can bring people in, utilities, NETA companies, and train them on how to use this equipment correctly on real life cables, hands-on, where people can get a good feel for the application, interpretation, and how to hook into different types of interfaces, elbows, separable connectors, live front terminations, etc. So that has become a key part of migrating from a very simple test to a far more advanced type of diagnostic. And that's important because the demands on our cable infrastructure are getting higher and higher. We are putting these cables under more and more load, and so the reliability on these cables become even more important nowadays. And in my talk about infrastructure, I would like to see, particularly states like Florida, where you have a lot of overhead still today. Every time a hurricane comes and hits, a lot of the poles get knocked down. But I think in large part because of the capital investment of putting overhead underground, a lot of utilities don't like to do that. They would rather go back and repair the poles over and over again. But a lot of subdivisions now, a lot of people want their utilities underground, so more and more is going underground, and therefore the requirements for testing are becoming more and more onerous, and more testing is going to be required, not only by meter companies, but by utilities as well.
So we have new installations or old installations going underground. We also have we got zillions of miles of aging cable. And that's part of why the testing protocols have to change, because you got to know what to replace, whether that's overhead, especially underground. Now you got the issues, because most municipalities in the United States have underground, they're all underground. They got vault transformers, cables running everywhere. Talk a little bit about the challenges of an aging infrastructure as it relates to cables. And different tests find different problems, right?
Correct. Correct. So, as these cables age, particularly under wet environments, the number one source of degradation to the cable installation itself has been found to be water tree deterioration, where these water trees migrate through the insulation. And Georgia Tech, NETRAC, you know very well, they've done a lot of work in this area. And these trees grow, and almost like a cancer in the cable, until they cause the cable to break down. So that you're quite correct, the very techniques we use to detect water trees and to detect electrical trees, which are the mode that the cable ends up failing with, are two very distinct types of testing techniques. Tan delta, for example, is very effective on water tree degradation, but when it comes to the electrical type tree or partial discharge in the cable, then partial discharge techniques become far more useful and worthwhile. So generally speaking, on an aged network, we try and encourage the use of tan delta, because now we're looking for water trees. And on new installations, we look at things like partial discharge, because now you're looking at workmanship type defects, dig-ins, cut-ins, etc. So you're quite right. Two different techniques for two different applications.
That's excellent. So in every one of those things you mentioned, you're talking about people. People have to do this. And it is harder and harder to get engineers, number one. Even though we live in Atlanta and Georgia Tech's got a great engineering school, it's just hard to get people to go into the utility industry, into the testing industry, and then the tradespeople, the actual people doing the tests. That's more and more difficult. How have you handled it at HV?
It's a very difficult task that we all have. Everybody here at NEDA has the same problem, trying to get good people, good technical people. And I'm a member of the Power Engineering Society Insulated Conductor Committee, and what we've seen over the years is a total decrease in the utility participation at the highest level of IEEE. And that is not good, because typically the utility engineers were the arbitrators of how these standards and guides would come out. And now you've just left it to a bunch of vendors, which could be a good thing, could be a bad thing. And so this is
usually more of a bad thing.
Normally more of a bad thing,
because they're very self-centric.
They're self-centric. They tend to be biased towards their own product, etc. And the utility engineers used to be the arbitrator of that. They would moderate that. We don't need that. We need this. So that is a major problem. How we get young people enthusiastic and energized about electricity is a big one. What we try to do at our company is create a culture that it creates a really enjoyable culture at work. We have fun together, we joke around, but we get knuckled down and do the hard work.
I'd like to work for you. You're a fun guy.
And I think as long as you can create that type of environment where you are genuine, you are sincere, you care about your fellow man, and not just about the bottom line, I think you can create a culture where young people will come and join in this industry.
So I know HV was just acquired. How are you going to continue to maintain that culture?
So luckily the person that acquired us, the company, has really given us free rein to continue doing what we've done.
Right.
We've grown the company every year without fail, and they want to continue on that same trend line. So we are going to continue business as usual. We are one of the leading manufacturers and designers and suppliers of diagnostic equipment for medium voltage cable.
Yeah.
And we want to continue that, and we want to increase the base of what we can offer the clients so that they can better serve their cable network requirements, not only in the utility sector, but in the industrial sector as well.
Excellent. I want to switch gears a little bit. I want to go back to South Africa. We did some interviews about 5 years ago, and it was with folks from Eskom. And back then, there was a certain culture and there was a certain value. But I understand, not just because things change, DER, solar, wind, it creates a lot more confusion. Talk a little bit about some of the challenges that you see in South Africa, particularly with Eskom.
You know, when I left 24 years ago, Eskom was a net exporter of power. They had too much capacity. They would export it to Zambia, Zimbabwe, Mozambique, Namibia. Fast forward to today, and they can't even keep up with their current local demands. And there are various reasons for this, and a lot of it's in the press. You know, mismanagement, corruption, state capture, etc. But the bottom line is, you know, electricity arguably is the second most important medium out there, apart from air.
Right.
Water supposedly second, but you don't get clean water coming out of your faucet unless you have electricity.
That's right.
So arguably...
So you're moving electricity, because there's air, water, electricity.
And I'm an electrical engineer. So I've got to put it up a notch.
Yeah.
But if you think about it, so much of what we do and take for granted every day requires electricity.
An educated society must have electricity.
Correct.
Or you can't read.
You can't do anything.
Yeah.
So I'm a big believer in making sure that as a country, from a security point of view, from an economic point of view, because if you see what's happening in South Africa, when you lose electricity for 12 hours a day plus, you start to lose business confidence. The economy starts to tank.
Oh, yeah.
Crime goes up. There are many, many socio-economic issues that take place when you don't have power.
Right.
So we have to be very careful that we plan accordingly in this country to avoid the same type of catastrophe.
Yeah. And you compete for capital in order to grow, in order to build, because capital moves to where it can be the safest, highest return for that. And so consequently, that's going to affect South Africa's economy in a tremendous way. It'll be the outflux of capital instead of the influx of capital.
Quite correct.
Yeah.
Quite correct. Yeah.
Well, that's so. If you were king, what were the three things that you would do to be a solution for that?
I may get into trouble for this, but I would make sure that I put the right people in the right positions that are technically competent, have the skill set, are experienced in order to run that operation. Keep the government regulators removed from that, do some oversight, but let the utility run itself with the right people. If they could do that, they would create an infrastructure, they would create an environment that would be very healthy going forward. I think that simple change would make a huge difference in what's happening now with Eskom.
Well, you shouldn't get in trouble for that, because that's common sense, sir. Anyway, it has been a delight. Thank you so much for joining me.
Thanks very much. Pleasure, Alan.